Okay guys, in this problem, an engineer is designing a building that requires a simply supported beam to be used in part of the roof design. This beam will receive a uniformly distributed load across its length. The client informs the engineer that the original building plans have been modified, and therefore the beam will need to be 50% longer than the original length. All other characteristics of the beam will remain the same. How much greater will the maximum bending moment be in the new beam than in the original design? So the very first thing we can do here is go to our Civil Engineering Reference Handbook. For my version, it's page 34, which brings us to simply supported beam slopes and deflections. So the maximum moment there for the type of beam that is described. So let's draw out the beam real fast. I would just take a screenshot for you, but I don't want the NCEES to ever come in here and say that I'm sharing parts of their book without their permission. So instead, you guys have to deal with a really badly drawn beam, and I'm sorry about that. Anyway, so this is what type of beam is being described, and we can see from the image that the maximum deflection is going to be in the middle. And the equation in the PDF as well is even written out. So we have the moment, sorry that's a bad M, moment. The max moment here at the center is going to be equal to W times L squared over 8. Now all we have to do is look at, so this would be the length, and if length L is the length of the original beam here, and then we want to look at a beam that's 50% longer, we can create a new max moment and say W times 1.5 L squared over 8. And if we solve that and expand the equation just a little bit, we get 2.25 L squared also over 8. And we can see by comparing these two equations that all of these terms would cancel out except for the 2.25. So the maximum bending moment in beam number 2 would be 2.25 times greater than the maximum bending moment in beam number 1. And that is all you need to do to solve this problem.